Alright, this video lesson 4, I will explain 2 examples. Alright, the first work example is quite common in examination. So here we have a beam, and there's this pivot is right here, okay, and this pivot, and this is the force W downward over here, and another force 25 Newton, okay, 25 Newton is over here, okay, and right, and there's this perpendicular distance for 25 Newton to pivot is given 45 cm, okay, and another perpendicular distance from W to pivot is 15 cm, and the beam is balanced. So according to the principle of moment, so clockwise moment is equal to anti-clockwise moment. Okay, so what is the formula of moment? Force times perpendicular distance. So let's start from clockwise. Clockwise, the force is W multiply 15 cm, so it's equal to anti-clockwise moment. W is a clockwise moment, and here is the anti-clockwise moment, is 25 Newton times 45 cm. Okay, so here we have W times 15 cm equal 25 Newton times 45 cm. Right, so in order to get W, you have to move. Right, so you move the 15 cm to the other side, so the multiplication become division. So this is how you get W. It's 25 Newton multiply 45 cm, and divide by 15 cm. Okay, so you will get 75 Newton for W. Okay, so it's important for you to identify your clockwise and your anti-clockwise. So this is your clockwise and this is anti-clockwise. And how do you know? By assuming this P as your center of your clock. Okay, and from there you can based on the principle of moment to solve this problem. Okay, right, let's move on to the next problem, which is a very common in exam. Okay, where they involve more than one moment. It can be 2 or 3 moments. Let's look at this example. This is the beam, alright, and this is the pivot, the center of the clock is over here. Now, W is here, downward, and 10 cm is the distance between W and the pivot. And we have 2 forces here. One is 15 Newton, okay, the other one is 25 Newton, 5 Newton. And the distance between 15 Newton and the pivot P here is given as 15 cm. Okay, and the distance between the 15 Newton and 25 Newton is given as 20 cm. Okay, first you have to identify which one is your clockwise and which one is your anti-clockwise. So by looking at the P, your pivot point as the center of the clock, so it's quite obvious W is your clockwise moment. And then your 15 Newton and also the 25 Newton will produce anti-clockwise moment. So meaning you have 2 anti-clockwise moment balanced by 1 clockwise moment. So when you solve the problem, let's go back to the principle of moment. It says that clockwise moment equal to anti-clockwise moment. Okay, so you must start from the clockwise moment equal to anti-clockwise moment. This is the principle of moment. So the clockwise moment here is force, which is W, times the perpendicular distance to the pivot is 10 cm. Okay, and equal to 2 anti-clockwise moment add up together. So let's start from the first one, which is a 15 Newton. So 15 Newton time the perpendicular from 15 Newton to P is 15 cm. Because this is the first one. Okay, the second anti-clockwise moment, force is 25 Newton. Now this part, the perpendicular distance, you have to be very careful. It is not 20, it is from the 25 Newton all the way to the pivot, which is 20 plus 15, which is 35 cm. 35 cm. Okay, so when you solve the problem, so you will find out the W here again is equal to the amount, these two amounts add up together, and then divide by 10. Okay, so 15 Newton times 15 cm, okay, plus 25 Newton times 35 cm divided by 10 cm. So you get the answer is 110 Newton. Alright, that's all for these two work example. In fact, these two examples are very common in exam. Try to understand, and if you have any question, do ask me in the next Tuesday physics lesson in the classroom. Alright, thank you.